welcome back, guys, to the IEEE Cyber Science 2020. So this is the first day of the conference, Monday, June 15, 2020. This is session 1, track 1, focusing on critical national infrastructures and CERT. And the last talk for today is titled Automated Artifact Relevancy Determination from Artefact, Metadata, and Associated Timelines events. And that will be presented by Xiaoyu. So with that, would I hand over to you to present?
So can I start now? Hello everyone. My name is Xiaoyu. I'm a PhD student at UCD. My research focuses on automated data forensic analysis. Today, I'm here to present our research work on automated artifact relevancy determination from artifact metadata and associated timeline events. Co-authors of these papers are Scanlon, with my PhD supervisor lecturer at UCD. Quan is a researcher in machine learning from CETA. In my talk today, I will firstly present the background of my work and then talk about the proposed methodology. Thirdly, it's about how I set up experiments to evaluate the approach. I created the disk image at VirtualBox for testing. 3 case scenarios for testing the approach will also be described. Experiment results and limitations will be presented. At the end, the future work part will introduce you how could improve the approach to fit more investigation scenarios. I just cannot move it to the next slide. Okay. Cybersecurity is more focused on the design of secure systems, the prevention and detection of attacks, whereas data forensics deals with the investigation after the incident. That's to say, when cybersecurity fails to protect systems from damage, it requires data forensic practitioners to investigate how an incident happened. Besides civil or criminal cases, for instance, child abuse, financial fraud, require data forensic investigations. In this digital age, the huge amount of data waiting for analysis has led to serious backlogs in law enforcement. For digital forensic analysis, the automation on discovering the story on these devices and auto approach for detecting files relevant to the investigation. Automated approaches for more efficient and effective analysis are widely discussed in the field. The current open source and commercial tools enable automated artifacts extraction from the seized device. From this slide, you can find how the information on a disk is visualized by investigation tools. Timeline analysis is also very important during investigation. So digital events extracted from a variety of log files, browser history, etc. At the left up here, a timeline viewed a timeline view from a commercial tool called Magnet. The number of events on each day is shown there, and so downside is a table. There are numerous low-level data events of file creation, access, modification, and so on. At the right is from another open source tool called Autopsy. For disk image analysis, it shows files as they are categorized by file types, images, videos, audios, documents. Also, recent files are shown because the time close to the investigation could offer interesting information. Yeah, as we have seen, there are too much information from a disk image. Even with this very clear artifact visualization tools, it is challenging to find out what is relevant to an investigation. The question, how to automated find illegal file artifacts. Actually, machine learning techniques have been applied for data forensic research. When it comes to machine learning, a very popular technique for various research problems, we basically know it works through training a dataset to get a model for classification, clustering, or regression task. The diagram in this slide shows the basic process of a classification model. There are many applications developed for forensics and securities. For example, network analysis, digital devices triage during the investigation, illegal file detection, or timeline reconstruction, and so on, many others. Network traffic analysis works through capture the network packets normal and abnormal situations to train a model for network risk prediction. Similarly, it is used for digital device triage to find out what digital devices could contain more useful information. All these applications train machine learning model before the investigation. However, use the trained model as the investigation can only detect illegal files. Some files could offer information to the investigation, but they might not really be illegal. How to automatically detect files relevant to the investigation? This is the question. So, in my research, the automated file analysis trying to look at so some files has been detected as illegal. So with very similar event files with very similar event to this non-illegal files, they could be relevant to the investigation, or say they are more suspicious. Assuming that a suspect uses a web browser to download a couple of files, put them into the same folder, and zip them, send it out by email. Yeah, for these files, they similar digital events recorded. So machine learning model could be used to detect them by the similar usage pattern. So this diagram shows file timelines are generated from search from digital image timeline. So the digital image timeline is also called a super timeline. which integrates all logs on the disk. In my experiment, the disk image is from a virtual machine. The VHD format is converted to a RAW format. Then the tool is applied for that disk timeline generation. So yeah, this slide shows us an example of a file timeline. It is preserved in a CSV file. This is a PNG files timeline called invoice.png. In this CSV file, each row represents a digital events occurred on the file. You can see the source from different sources. There are file or means from file system. There are LNK from link from Windows system. Web host is from Chrome, and REG Windows registry. Yeah, many different type of sources associated with these files are extracted for in this to generate to get this file timeline. So to get my data set for each file from each file to generate a file timeline like this. Features that represent the file activities can be extracted from file timeline. For example, the high frequency words or the number of digital events or the what kind of digital events type happened on the file. Yeah, file timeline generation is not a very common operation in data forensic analysis. It is used for feature extraction in my experimentation for training machine learning model to find out files usage similarly to illegal files. So machine learning model is trained for relevant file prioritization. Actually, as described, the relevant files have something similar to the detected illegal files. They are probably illegal, or they could offer key information for the investigation. The process of this method is the first step, file hash comparison to identify non-illegal files and benign files, and at the same time highlights previously unencountered files. The second step is the file timeline extraction, which has been presented. Then it is model training. I use spot vector machine. The trained model in the end can be used to get a relevancy score for the unencountered file. As the label is binary, it can only be trained as a classification model. The coefficient of the model are used to generate a number called the relevancy score in the research. Rank the unknown file artifacts by rank the unknown file artifacts by its relevancy score, enable the investigator to detect illegal or relevant files by reviewing less file artifacts. The relevancy score stops or prevent the investigator from wrong classified file artifact. So this diagram shows how relevancy scores are generated during the investigation. The known files train the model. These known files are detected during the investigation. the model is trained during the investigation actually, hence allow the use of digital events as a feature to detect file with similar usages. The annual file's relevancy score are calculated by the value of each feature. The sum of each feature multiply the coefficient is the relevancy score one file get. The idea of generating scores from machine learning models also used by Professor Nicole Bibb in their work ranking algorithms for data forensic string search hits. Yeah, almost all classification models work through a possibility of the class. So this possibility of it being illegal can be converted to a relevancy score. For the experimentation, I use the generated disk image, which is a Windows image that works within VirtualBox. It is a Windows 10 system with several softwares installed, such as Chrome, WinSCP. I did criminal action emulation manually. Yeah, the files are labeled as illegal. Also, there are some other wear and tear generated by automated tools. They are benign files. For timeline generation, I use the log2 timeline, also known as the Plazo. It is to enable to extract data events from all different levels of information recorded on the Windows machine, such as the master file table from the NTFS file system, Windows registry, web browser history, and so on. Then a developed script search file name from the disk image timeline. The returned result generates a file timeline. I conducted an experiment on this generated data set, trying to split the data set from training and testing. I even tried to use 20% of files as known file for training and testing the rest 80% files by doing this to find out the performance when only a small number of files are detected as the known files during an investigation. Now let's say the 3 case scenarios I emulated on the Windows machine. One is for child sexual exploitation material investigation case. Some illegal files are with web browser data events. There are also copy and moving actions. So the model hope to find similar actions by using features of Chrome, child, PNG, MFT. The second case is a hacking case, assuming the suspect's computer Python script name password cracking, and some other text files are found through keyword search to build for relevant file ranking. The features used are hack, Python. Yeah, the third case are related to financial fraud, also based on the known files to define what features to use. Maybe through search the similar the specific keyword how many times shows on other files to determine the similarity of unencountered files or unknown files if they are probably suspicious. Yeah. The purpose of this research is to prioritize the file artifacts for investigators. We were expected to rank the more relevant file artifacts at the top. The table in this slide shows the performance of the approach tested on 3 case scenarios. The result shows when reviewing 30% of all artifacts in different cases from 79% to 89% of all illegal files can be found actually. In fact, this experiment uses a small data set with only hundreds of files because the file timeline generation takes quite a long time. Yeah, it can be improved by parallel processing. Also, better performance can be expected when it is with a larger data set. But yeah, it is obvious still a limitation of this approach, which is with very high uncertainty, as can be seen in these 3 cases. The results are different, so bad performance could occur when applying to real case investigation. So this approach offers an option for automated analysis. It is not designed to replace any existing approach. It can be chosen to assist the investigation. So yeah, about the future work, computer vision and natural language processing techniques could also apply to the process, to the file artifact prioritization approach. For a child abuse case, pictures are the file type mainly focus on for examination. Yeah, these techniques have developed applied to many applications, but for forensics purpose, the main challenge is lacking of a data set. I've tried a little bit on applying pre-trained image classification model, ResNet 50 on a data set of images. I put 1,000 samples for each class, achieve around 95% accuracy. It would be nice and not complicated to apply this approach to real investigation. So yeah, thank you very much for listening. Hope my presentation is clear to you. Now, do you have any questions? I will check here.
Thank you, Xia, for your wonderful presentation. That's really good. I've learned quite a bit from your timeline of events and how you use that for the artifacts and analysis. But I have a question, but before then, let me go to the Q&A to see if there is any questions there. Okay, that's still ongoing. So I have one question is, what is the size of the data set you use for your machine learning? There was an aspect of your work that involved machine learning. What is the size of the data set you used?
The data I used shared documents from digital corpus. I use these files to inject to the Windows device to labeled some of them as illegal with very illegal actions emulation. So trying to train model to detect them.
In terms of size, do you do that in the number of files? So was it like 1,000 files, 1 million files, or did you do that in terms of the terabytes, in terms of the size? So I'm looking at the data set, that, you know,
Yeah,
it's
a small data set, assuming yeah, not much files on that system machine, and test. Yeah, it's very yeah, just start at this work and having to test a larger one. Yeah, from the submission of this paper till now, I have done another with 1,000 image files pictures for doing that classification is get a higher performance.
That's all right. I mean, I also was impressed with the number in terms of percentage. So when you did 10%, 20%, 30%, the results were quite good compared to the 50 and 100, which means with a smaller data set, you could actually infer, there would be high inference in terms of the detection of the artifacts that are of interest. So the other question for me is, how did you compare the file hashes? Because the hashes are quite difficult, and most times they're not encryption, they're hash, which is difficult. So how did you compare hashes to get to how you then start to say, okay, this particular one is illegal or not legal? What techniques or method did you use to compare hashes?
Yeah, actually, hash database comparison is not a part of my research, but I know most forensic tools, as I presented the commercial tools, when you get that your disk images, they will show so the hash and the known files. This is a very common approach used in forensic. So as a first time, as long as it's not encrypted, if one disk is encrypted, then it's another problem. But yeah, as long as it's unencrypted, so there are many commercial tools used to hash each files or even clusters on the file system to compare against the known database to highlight the unknown for further analysis. So yeah, to save, to repeat this work again and again. Yeah.
Thank you very much. And with that, we've come to the close of day one. Just to remind you, tomorrow we're starting again at 1100 GMT plus 1, so 1100 UK time. We're starting tomorrow. In fact, there are 4 tracks tomorrow, and there are 2 keynote speakers. So the first keynote speak is at 1500 GMT plus 1, and that's from Dr. Philippa Spencer of DSTL. And at 1830 GMT plus 1, Dr. Jason Nurse, assistant professor at University of Kent, would also provide a keynote speak. Tomorrow we have double act, which means we have a workshop happening tomorrow, the international workshop on cyber insurance and risk controls. And also tomorrow is our machine learning for insights and cybersecurity and situational awareness. So I look forward to seeing you guys again tomorrow. It starts again 1100 GMT plus 1 on the dot. Thank you, everyone, and see you tomorrow. Have a good evening. Cheers. Bye.
Thank you. Bye.